The transition from sodium lights to LEDs, the so-called lighting revolution, was supposed to reduce energy consumption and bring back starry skies, but new satellite data indicate it's not working out that way. When scientists are disappointed with the results, it's usually because they were following a different hypothesis than where their data leads. In the case of the switch from sodium lights to LEDs, though, it's more than that. Honestly, I had assumed, and hoped that with LEDs we were turning the corner, says Christopher Kibbe, German Research Center for Geosciences. Kibbe researches the spread of artificial lights and how it affects our nights, and is a former member of the board of directors of the International Dark Sky Association. He also advocates the use of improved lighting practices. But in the November 22 Science Advances, Kibbe and colleagues show that we are farther from the goal of dark, starry skies than ever. World maps showing the rates of change of the lit area of the world left and the measured brightness of each country right during 2012 to 2016. Warmer colors in each map correspond to higher rates of change. Note that Australia is an odd case. Wildfires increased the country's lit area, but this effect was not included in the radiance analysis. Kibbe al. Science Advances More Lights, Brighter Nights Outdoor Lighting in Doha, Qatar. Between 2012 cyan and 2016 red is seen from the Suomi satellite. Areas newly lit since 2012 appear in bright red. Kibbe al. Science Advances. The team used the Visible Infrared Imaging Radiometer Suite VIIRS instrument on the Suomi National Polar Orbiting Partnership weather satellite to measure the change in global light emissions between October 2012 and October 2016. The VIIRS instrument is the first ever calibrated satellite radiometer designed to measure nighttime lights. Earlier investigations were often based on uncalibrated sensors on military satellites. VIIRS observes the day-night band DNB, which picks up visible through near-infrared wavelengths. Each pixel covers half a square kilometer, a higher spatial resolution than previous instruments, which enables scientists to investigate neighborhood-scale changes, rather than city or national, for the first time. The researchers' findings will not please astronomers. Earth's nights are becoming brighter. Between 2012 and 2016, the artificially lit outdoor area on our planet grew by 9.1%, an annual increase of roughly 2.2%. Additionally, already lit areas also got brighter by 2.2% per year. Only very few places show a decrease in lighting, mostly war-torn countries like Syria and Yemen, while some of the already brightest lit countries remain stable, among them Spain, Italy and the United States. With few exceptions, all countries in Asia, Africa, and South America emit significantly more light now than they used to 5 years ago. That in itself isn't unexpected. Artificial lighting has long been an indicator for growing wealth and population. What's surprising is that the ongoing transition to LEDs isn't having a contrary effect. While we know that LEDs save energy in specific projects, for example when a city transitions all of its street lighting from sodium lamps to LED, Kibbe explains, when we look at our data at the national and the global level, it indicates that these savings are being offset by either newer brighter lights in other places. Changes in the color of Milan, Italy, at night between 2012 left and 2015 right, between which the outdoor lighting in its urban core was transitioned from high-pressure sodium vapor to white LED. International Dark Sky Association NASA. It's a rebound effect. Cheaper lights lead not to savings in energy consumption, but to more light. And that's not just bad news for astronomers. Since the first emergence of life, the biological world was organized to a large extent by natural cycles of variation in light, explains Franz Holker, Leibniz Institute of Freshwater Ecology and Inland Fisheries, Germany. From an evolutionary perspective, artificial light at night is a very new stressor. Because electricity brings light to places, times, and intensities at which it doesn't naturally occur, many organisms have no chance to adapt. The natural light cycles are fundamentally disrupted. About 30% of vertebrates and more than 60% of invertebrates on our planet are nocturnal, but outdoor artificial light also affects plants and microorganisms, and scientists are only beginning to learn about its possible negative effects on human health. Blue versus amber LEDs. To make matters worse, the DNB is insensitive to wavelengths below 0.5 microns blue light, which the atmosphere scatters more than other visible wavelengths. Unfortunately, many popular LED lights peak at these wavelengths. It doesn't have to be this way. One of the really huge advantages of LEDs is that it's possible to make very many different colors, Kibbe insists. Cities can buy lamps that are not white, that have this blue component completely removed. However, these PC Amber True Amber lights are so far used almost exclusively in designated dark sky places. Nevertheless, Kibbe and his colleagues remain open to working with cities, local governments, and industry partners to reverse this trend. The real dream is that we have great vision on the streets, never really experience an uncomfortably dark place inside of a city, but because the light is used much more efficiently, would have more stars to see in the sky. Find more information and resources for local change in Sky Telescope's Saving Dark Skies section.